Good morning everyone. Now I am starting my today's class. Our topic that is benzene and its derivatives. So I am starting from where I finished in my last class. So it's a Huckel rule to be a aromatic compound. So you have already studied what is Huckel rule, and you can see also one thing you have to remember in that you cannot shuffle this order. You have to maintain this sequence. First you check for rule number 1, then rule number 2, then rule number 3, and finally comes to the rule number 4. You cannot start it from rule number 4. Now I am telling you a very important thing, that all aromatic compounds are most stable compound in our chemistry. So you have to memorize this statement because it can come in your exam as like true and false. Now come for anti-aromatic compound. So I am starting with a drawing. Just wait for a few seconds. Okay, now tell me this compound is aromatic or not. So first you have to check rule number 1, that is it's cyclic compound. Okay, second one is it's maintain the conjugation, or you can say having delocalized pi electron. Very good. Next, rule number 3. Compound is a planar and having sp2 hybridized. Now finally comes to your rule number 4. For this compound, we can see that it's having 2 pi bond, or you can say 2 double bond is there. So that's mean 2 into 2, that is total number of 4 pi electron is there. But it is not present in our Huckel rule for aromatic compound, so it is not present in our series. That means this compound is not aromatic compound. Now comes for Huckel rule for anti-aromatic compound. In this rule, first 3 rules are as same as Huckel rule for aromatic compound. Just the last one is different. So the rule is 4n pi electron. Here is 4n pi electron. And the value of n is started from 1, 2, 3, 4, and it's go on. So in this case 0 is not possible. But why? If we are putting the value of n, that is 0, so here is 4 into 0, that is total number of pi electron becomes 0. So that is not possible because our compound having maintained the conjugation, having the pi bond is there. So that's mean total number of pi electron not be a 0. So that's why in case of anti-aromatic compounds we are starting the value of n from 1, not from the 0. So this is the main difference from Huckel rule for aromatic compound to Huckel rule for anti-aromatic compound. Now another more important point, that anti-aromatic compound is very unstable. On the other hand, aromatic compound is the most stable compound in our chemistry. So it's a very unstable. Very unstable compound. Now finally come for non-aromatic compound. So what is the definition of non-aromatic compounds? So compounds which are neither aromatic nor anti-aromatic. So they are called as non-aromatic compound. Okay, I'm just make some drawing for non-aromatic compound. Just wait. Now you can check one by one Huckel rules for aromatic compound and also for anti-aromatic compound. So first one, it's not a cyclic structure, so that's mean it's neither aromatic compound nor anti-aromatic compound. Second one and third one, both are cyclic compound, but they don't have the conjugation process, only one pi bond is there, so that's mean it's neither aromatic compound nor anti-aromatic compound. So both three compounds are non-aromatic compound. Now, very important part, arrange the stability order. So what is the stability order? Is aromatic compound is the most stable compound, then non-aromatic compound, then anti-aromatic compound. So anti-aromatic compound is the less stable compound, or you can say it's very unstable compound. Now I am drawing some important and little different compounds. You have to just check which type of compound is it. Okay, so just wait. Okay, I am first giving you a instruction that if you find that any lone pair or cation or anion is present in your structure and it is part of your conjugation process, then you have to count it that lone pairs or electron as your pi electron. Understood? Okay. Now all this diagram you can find that all are cyclic compound. All are cyclic compound. Okay. Now next is conjugation. So in this diagram you see that double bond is there, then single bond, then double bond, then again single bond, then again double bond. So conjugation is there. As same this one also maintain the conjugation is there. One thing I'm just told you that if a molecule directly attached to the pi bond, directly here is the nitrogen atom directly attached to the pi bond, or you can say double bond, it and it can have also a lone pair. In that case lone pair is not required to participate in this conjugation, but in this case here the nitrogen atom not having any pi bond, not having any pi bond with it, that's why the lone pair is participated in the conjugation process. So it is also same for both these compounds also. Here little bit different in case of furan. So here oxygen molecule having two set pair of lone pair, two set pair of lone pair, but only one set pair of lone pair is enough for conjugation, which is inside the ring. Remaining is not required and it will not be counted as pi electron. Okay, next is having this compound having double bond, single bond, double bond, single bond, having cation, so maintain the conjugation process as well. Okay, next is here you can see that only one pi bond, or you can say only one double bond is there, so delocalization is not possible for this particular compound, so it's not maintain the conjugation process. So it is our non-aromatic compound. Now all these compounds also having delocalize pi electrons and maintain the conjugation as well. You can see double bond is there, single bond, double bond. So this double bond sharing in both side, so it's also maintain the conjugation process. This compound also maintain conjugation process, and this one also, here is double bond, single bond, lone pair is there, so it's maintain the conjugation process, again single bond, again double bond. So this all three compounds also maintain the conjugation process. Now comes for the last rule, that is the total number of pi electron we have to be counted. So we are starting from here. So here only 2 pi bond is there, no lone pair is there, so that's mean the total number of pi electron is 4. So this compound is, simply we can say that is, it's a anti-aromatic compound. Okay, now here is you can see that 3 pi bond is there, here also 3 pi bond is there, lone pair is not participation in your conjugation process. So that's mean both to these compounds having 6 pi electron. So here is 2 pi bond is there, one pair of lone pair is participation in your conjugation process. So here also 4 and 2, that is 6 pi electron is there, here also 6 pi electron is there, here also 6 pi electron is there. So all these compounds are having 6 pi electron. Okay, comes to the double ring structure. You have to count it, both the rings having how many total number of pi electron. So all three having total 10 number of pi electron, total 10 number of pi electron. So you can just count, here is 2 pi bond is there, here is 3 pi bond is there, this lone pair is not be part of your conjugation, so here is 3 and 2, that is total 5 pi bond is there, that's mean 5 into 2, that is 10 pi electrons. So here it is 3 pi bond, here is 2 pi bond is there, so total number of pi bond is 5, so that's mean 10 pi electron is there again. And here also 3 pi bond is there, 1 pi bond, and here is one set of lone pair, so that's mean here is 3, that means 6 pi electron, and here is 2 and 2, that is 4, so 6 plus 4, that is 10 pi electron is there. So all three these compounds having 10 pi electron. So that's mean all these 8 compounds, here is 5 and here is 3, so all these 8 compounds are become aromatic compound. Understood? Okay, so this is our whole summary for this topic. Here you find that the difference between aromatic compound, anti-aromatic compound, and non-aromatic compound also. So you just pause the video and you can note down it. So for today's class, that is enough. Thank you everyone.